This Fleet Equipment Unscripted interview is presented by Hendrickson, a leading manufacturer of heavy-duty suspension systems and components to the global commercial transportation industry. Visit hendrickson-intl.com to learn more.
Hey everyone, Jason Morgan, Content Director for Fleet Equipment. Welcome to Fleet Equipment Unscripted. I am at Hunter Engineering in St. Louis. Now, I was talking with the Hunter folks back at TMC, and we looked at the HawkEye XL alignment system, and they were talking about how easy it was. I'm like, well, how easy? Could I do it? Is it that easy? And then they said yes. And then I knew I had to come do it. So I'm here visiting Hunter, and we're going to run through a heavy-duty truck alignment on the HawkEye XL. We'll see if a non-technician, non-technical person can actually do this, and if the system makes it easy. So let's see what happens. Run me through some of the alignment basics, though. Let's pretend that I don't know anything about alignment, which is not very difficult. I mean, how often should fleets be doing this? What are some of the telltale signs you're out of alignment? And where do you really see that impact either maybe tire wear or fuel efficiency or anything like that?
Yeah, so anytime a vehicle's out of alignment, you're going to see tire wear or fuel problems. And in the fleet business, the big thing about that is that our two biggest expenses most of the time is going to be fuel and tires. So if we can get that thing to run true, a couple of telltale signs, if you're behind a semi-truck and you ever see the side of the trailer instead of the back of the trailer, that means that trailer is not aligned to the tractor. Mm-hmm. We're creating a pulling thrust or more drag on it. Right. But not only that, but it could be a safety concern because we're edging into a lane. Mm-hmm. If we think about the truck, it's the same kind of scenario. If we have a scrub angle, so those axles are splaying away from each other, it's going to create the vehicle to try to make a corner. In turn, the driver has to turn into that pull it's creating, and that'll cause not only scrub on the tire, so we'll have outside edge wear on the right-hand side, inside on the left side, but it's also driver fatigue. Okay. And when these drivers are on the road for extended time periods, we need to make sure that they're fresh. And if we're fighting that vehicle the whole time as we're driving, that driver fatigue can kick in, and we can start having some issues there.
Do you find it's that driver feedback that raises the alignment alarm bells a little bit, that the truck needs it, or do they see it maybe in that tire tread width from a fleet manager perspective, right? Someone back at the home office. So
there's two different ways fleets handle this, and the majority of them do it this way. They'll bring it in for a PM, they'll see abnormal wear, they'll do an alignment. So that is the reactive type scenario. Right. But with some of our inspection equipment, we would recommend to be proactive and catch that before it causes the tire wear issue. Right. And we can usually, if we catch that and do a maintenance alignment to make sure it's in alignment the whole life cycle of those tires, we get 20–30% more life out of the tires. Yeah, so we need to make sure we know the tire diameter for the manufacturer specification. This is a caliper Hunter's put together so we can make sure we find the proper diameter of the tire. What we need to do is put that at the furthest 2 points of the tire, push it in until it comes in contact. Then we can pull that clamp off, and if we look on there on that scale, it's going to tell us how many inches it is, and we can input that into the machine, and then it'll calculate the toe that's needed for that particular axle and that tire diameter to get the best wear and tracking for the vehicle. What we have here is we're going to have self-steering wheel clamps that are going to attach the targets to the wheels. You'll see one of the wheel clamps has an offset on it, so that's going to be at the rear axle to offset it so the cameras can see both targets. Okay. When we pull this off, we have an indicating arrow pointing up. That's telling us that needs to go up when we're on the vehicle. So this particular target would go to the right rear. At that point, we're just going to rest those fingers on the edge of the wheel. Yeah. Tighten up the clamp on the top side of the wheel. Our only step we need to do after that is just make sure that arrow is pointing straight vertical. Okay. And then we'll do that in all of the other wheels so it has something for those cameras to lock into. So Jason, we're going to go over your work, just make sure you got it right. You did a great job. I was watching you apply those clamps, and that self-centering clamp, we just make sure we grab the outer edges of the wheel. I saw you paying close attention to that arrow, making sure that's vertical or straight up and down. That's really important. Besides that, you did a great job. You can see as we look down the truck, the back target is offset from the front target. We need that so the cameras can see both targets.
Yeah, so tell me about that. So now that we got the targets on, the cameras can see them up over there. What are the cameras actually looking for as we get ready to roll this thing forward?
So the cameras are looking at these reflective strips on here. So the reflective strip here, and that's a 3D effect because they're offset. And then it's looking for identifiers, so these black marks and silver marks through here. When it sees that identifier, it knows where it's at on the truck, and then it's using these to pull the angle. So we're going to mount that on there, and as we roll that forward, any mounting error we have between the clamp and the wheel that we might have induced as being a technician.
I don't know what you're implying here, sir, but I understand. I'm going to need that double check.
Yeah, so when we mount that, we need to take out any of that human error, and when we roll that vehicle forward, it can calculate the mounting error and come up with a true number.
Okay. Does it show you the mounting error? Like, are we going to see that on screen, or it just gives you the number? Okay, good.
It just gives you the number.
Good. Not calling anyone out here. But so just from that, so the targets to the camera, just from that, the little bit that we're going to roll here, right? I'll even get a little look there. Just that amount of rolling forward is going to be able to give us the alignment information.
Yep, it's going to give us all the information we need to calculate the alignment on all 3 axles.
Okay, let's do it.
All right. All right, guys, to begin this alignment, we need to hit begin alignment. Once we do that, we need to pick the vehicle we're working on. This particular truck's going to be 3 axles with the last axle as a rear reference. So we're going to go ahead and pick that. Now we're in our spec library. We want to go down to heavy duty if we're doing trucks, but if you had a light duty vehicle you're going to do an alignment on, you could pick light duty. Once we confirm that, we're going to confirm the manufacturer. This particular vehicle is a Volvo. Once we do that, we pick the submodel, and then we can go on to our specification. You'll notice the yellow stripe at the top of the screen. The yellow stripe is asking for a toe reference diameter to be entered. You'll notice there's no toe specs listed because we do not have a overall diameter in the machine. We use that caliper to measure the overall diameter. We know it's 40.5 or 40.5 inches. So if we enter that and push enter, you'll notice that it populated the specs that are associated with the diameter of the tire. Once we get all that information, now we can mount the sensors and start our compensation. So if we hit mount sensors, at this point, it's going to give us instructions to block the wheels so it doesn't move, make sure the vehicle's steered ahead, and then we're going to roll that vehicle forward to make sure that we get that compensation done.
Another dumb question.
Go for it.
Tire toe?
Tire toe is the forward or inward or outward tilt of the tire. So
Okay.
as you're looking at the tire, if they're tilted in or pointing toward each other, that's going to be toe in, and toe out is pointing away from each other. So as we drive down the road, most vehicles have a little bit of toe in because the forces of the road pushing against it will take it to 0 when it's dynamically ran.
Okay, interesting.
And that's something the axle manufacturer takes into account when they're engineering it, that they know that deflection is going to be in there and they're going to calculate into that spec.
Okay, very cool.
Targets on there, it's identified the targets. It actually took its first measurement, so now it's asking us to roll that truck forward. So what we're going to do is go around to the back of the vehicle or the left rear of the vehicle and use our pusher that Hunter provides to help push that vehicle forward. All right, guys, we're going to use this truck pusher made by Hunter to help push this truck forward. So we're going to set it in behind the tire. We have a little safety button we're going to push down, and when we push that handle down, it's going to just roll it forward. Once we get it where we need it, the alignment machine is now going to take its second measurement, but it also works as a wheel chock, so it's going to hold that vehicle in position. So we rolled it to get the compensation to make sure we find true 0, and we can find that alignment. And then you heard that noise, it automatically unlocked the turn plates. So now we're ready to check our caster and then continue on with our alignment. All right, guys, so the next step in this is going to be measure caster. We've pulled camber and toe on all 3 axles, so we know exactly what's going on here. We know we have a thrust angle that's out of spec. Our total toe looks good. Our scrub angle's out, our toe out on the front, but we don't have any information on caster. But the machine knows the next logical step is to measure caster. That's why that's a K4 button. At that point, we're going to initiate measuring caster, and then it's going to walk us through that step. It says, go ahead and service brake should not be applied. Steer the wheels as directed. So we're going to jump in the truck and turn that steering wheel until we center that bar graph, and it'll walk us through step by step. And then the machine knows the next logical step. Because it knows how to do the alignment, it's going to automatically go to the next step we need to accomplish the task and accomplish it correctly. So we're going to set that thrust angle off that rear axle, and then we'll move our way up the truck. So on this rear axle, we're going to use a couple different tools. One's going to turn that eccentric, the other's going to loosen the nut so we can turn the eccentric. So we're going to use our wrench, we're going to get it on the nut, and just like on our light duty stuff, we're going to loosen this. Once we get a little movement in there, we can use our tool, put inside of that cam or that eccentric, then we can just use our wrench to adjust that cam where we need it. So we're going to adjust this way, and we might need to loosen that just a little more to make sure we get everything moving easily. So it does have a second cam there. So the bar graph is showing our tolerance. So this manufacturer wants it between 0.0 negative, or 0.08 negative and 0.08 positive. Right now we brought it down to 0.03. So it's well within the tolerance of the vehicle. And then it's going to ask us, do you want to go to the next step? If we hit OK and we like that measurement, we can hit K4 again. And then it'll go right into verifying that axle. And then it'll ask us, do you want to adjust the thrust? All these numbers are grayed out because there's no manufacturer spec on it, but it's good as a reference so we can diagnose bent parts, bent axle frame, bent axle tubes, or any other parts that might be associated with it. Since everything's in good shape, we can go ahead and adjust the scrub angle, and now we're on that next axle. So to adjust that, we're going to go through the same process, loosening those cam bolts, moving that cam to make sure that brings it right back in, and we're aligning that middle axle with the back axle, working our way up the truck. So we got the rear axle set, and we set the scrub angle, so that's the reference to that rear axle. We just hit OK, it's going to go to our next screen. Now we have the verifying that rear axle or that center axle. We have all the specs for that center axle. We can continue adjusting caster and camber. If we look at this vehicle here, you'll see a couple things are out of spec. We can make those adjustments if the vehicle allows those adjustments. If not, the main focus on this screen is going to be our toe. That's going to be our major tire wearing angle. If we look at our specs here, we're just a very minute out of spec, so I probably wouldn't even worry about that.
Well, why wouldn't you worry about it?
Well, when we look at the full spread of this, we're 0.11 out of tolerance. This has got a solid beam axle going across, so to adjust that camber, we would have to replace that axle or try to manipulate that axle. The axle manufacturers do not recommend manipulating or bending the axle for corrections because of the memory in it. So once we have this measurement, we're going to look at that and decide what we want to accomplish. If you did make a caster adjustment, we'd want to verify caster. If you wanted to see the next bar graph, this is going to be our total toe, which is what we're going to adjust on this truck because there's one toe adjustment, and then the steer ahead, and that's how we adjust to make sure the steering wheel's straight. At this point, because we have to get underneath the front of the truck and we're not making adjustments through the side, we'll use the rack to pick it up so we can get it in a comfortable work height. So we're going to use our Hunter rack to pick this up, and we can access the bottom of the vehicle. To run this rack, we have the raise lower button and lock release. All we need to do is hold that raise button and it'll start picking the vehicle up. Once we get to a comfortable height, you heard the locks engage. We just need to hold our lower button until it comes down on the locks, and then we're ready for our adjustment. So this one, we'll get down on our knees to make that adjustment.
I'm good at tightening.
front toe. So now we've adjusted all those axles. The next step is to verify caster, and you'll notice this is express align. It's putting a check mark in every step we've done. So we've gone through and saved before measurements. We adjusted the rear axle, the scrub, and now the front toe. And now it's asking us to verify that caster, and then we can go ahead and print it and send it up to HunterNet. So if we go ahead and hit K4, which is the next logical step, verify caster, you'll see that same screen that popped up before, and we're going to center it, swing 10 degrees each direction, and it'll give us that number. The way we're going to lower this, we're going to pick it up off the locks. And once we get it off the locks, we're going to hold the lock release down. That's going to disengage those locks as we lower it down to the ground. Keep an eye on the vehicle, making sure everything's coming down safely. And we can bring it all the way to the ground. Or if you want to have it at a certain height, you can stop at any height and put it back on the lock. So we look at the screen now, we have our total toe and then we have our steer head. So that's the angle the steering wheel is at as it's driving down the road, referencing the rear axle. If everything's in good shape here and we validate that, at that point we can hit our print. We're going to see a print preview here. It's going to show what it was before, and then the next sheet would show after. We have a couple different screens we can print, but we'll go ahead and print this one. But if we could hit complete just measurements, the before and after vehicle is a little more friendly for non-technicians to read. If we just wanted to see the speed.
I agree.
We have bar graphs and we have tires, and we can actually show on those tires an image of on how they're going to wear, which is pretty impressive.
That is cool.
If we wanted to go down to just the current measurements, we can do current measurements, we can do before measurements, or if we do before and current, we'll actually get two printouts here. And your printouts would look just like this. This would be the before, and the after, you'd see all that in green. So we would have no tire wear issues.
That's it then.
That's it.
Truck's aligned.
Truck's aligned. Job's done. Making sure the driver's safe. He's driving down the road with less fatigue. Tire wear is a lot less, and then also decreasing fuel consumption. Any way we can help out those expenses by decreasing the fuel expenses and tire expenses, we're going to be in good shape in our fleets.
You mentioned, I believe it was HunterNet. Can you tell me about that? How does this live in a digital environment then after the work's done?
Yeah, so after the work's done, we can send that to HunterNet. That's a cloud-based storage for our customers. They can access that information, so if they need to look up the alignment specs before or email into a customer, they can do that all digitally.
Very cool. Well, thank you for taking the time, walking me through it. I appreciate it.
Thank you so much.
All right, so that's it. I did align a truck with some help, with a lot of help. But it wasn't as daunting or as challenging as I thought. The software walks you through it, doesn't let you move on until you do the next step. Dave was a great help, so now I am going to get these sensors off, put it back for the next actual technician to actually do some of these.